Welcome students to session number 63 of chapter number 1 physical world. Today we are going to discuss a very important topic that can be asked into 1 mark question, that is nothing but what? Conservation laws. Clear? So our topic is conservation laws. Before moving into the topic, I want to clear one thing over here, that in any physical process involving different forces, there are some quantities which remain unchanged with time. Means that do not change with time. There are such quantities which do not change with time, or you can say remains unchanged. Such quantities are known as conserved quantities. Such quantities are known as conserved quantities, and the laws governing these conserved quantities are known as conservation laws. Known as conservation laws. So we can write over here, that is, in any physical process involving many different forces, few quantities remains unchanged with time. So here you can write, in any physical process involving many different forces, some quantities remains unchanged with time. Such quantities are called as conserved quantities. Very good. And what I have told, that the laws governing these conserved quantities are known as conservation laws, and the laws governing the conservation of such quantities are called conservation laws. Is this clear? Okay. Moving ahead, I want to tell you, in classical physics we usually deal with 4 types of conservation laws. So I can write, in classical physics we usually deals with 4 basic laws of conservation. Yeah. Now somebody asking 1 mark question, that give the statement of following conservation law. Then you need to determine the statement for that law. So the very first law we do have, that is law of conservation of charge. Second we do have, that is law of conservation of linear momentum. Is this clear? Third we do have, that is law of conservation of angular momentum. Clear? And last we do have, that is fourth law, that is law of conservation of energy. Is this clear? These are the basic 4 laws in classical physics we usually deals with. The very first, that is law of conservation of energy, law of conservation of charge, law of conservation of linear momentum, and law of conservation of angular momentum. Now before moving into this laws of conservation laws, I need to discuss what is an isolated system. Let me clear the board, please. So we are going to discuss now, that is what is exactly isolated system, before moving to conservation law. Isolated system. Clear? Now isolated system, I want to tell you one thing over here, that any system that is assembly of particles or bodies on which no external force acting on the system, then such type of system is known as isolated system. So we can write over here, any system, bracket I can write assembly of particles assembly of particles, or you can say bodies, or body on which no force acts, on which no force acts, is called an isolated system. Is called an isolated system. Is this clear? Now talking about the very first conservation law, that is law of conservation of energy. See, law of conservation of energy that you have already studied in the lower standard. And what is law of conservation of energy? This law states that energy can neither be created nor can be destroyed, but it can be transferred from one form to another. Clear? I can give you simple example about electric iron. Yes or no? You're pressing your clothes. What happens? You are supplying electrical energy. In turns, it is converting that energy into what? Heat energy. It is converting that energy into heat energy. So the principle for electric iron is what? Electrical energy, conversion of electrical energy into heat energy. So I can write that this law states that energy can neither be created, energy can neither be created nor can be destroyed, but it can be transferred from one form of energy into another form of energy. Till this clear? Okay. Equivalently, you can say one thing over here. The total energy for an isolated system remains constant. So I can write equivalently, the total energy of an isolated system. Total energy of an isolated system remains constant. Clear? I will give you an example over here that if you are throwing a ball from top of a multi-storied building, what will happen? It will move under the effect of gravity. You will be able to note that the potential energy of the ball, which is attained due to height of the building, because it is thrown from a certain height, so it is going to have potential energy. This potential energy, while coming down, is converted into kinetic energy. Make sure at any point of its journey, the total mechanical energy remains constant. So what is total mechanical energy? Total mechanical energy is nothing but summation of kinetic energy and potential energy. Till this clear? So again I can write total mechanical energy, that is nothing but summation of kinetic energy plus potential energy. Till this clear? Moving to the second law, that is law of conservation of charge. The second law we do have, that is law of conservation of charge. Clear? Now you can say that this law states that total charge of an isolated system, remains constant. Which implies that charge can neither be created nor can be destroyed, but it can be transferred from one body to another. Clear? So this law states that total charges of a system remains constant, and it can neither be created nor can be destroyed, but it can be transferred from one body to another. Hope it is clear perfectly. Charge can neither be created nor can be destroyed, but it can be transferred from one body to another. Clear? Here there is no conversion, but here there is only transformation of charges from one body to another. Hope it is clear perfectly. Very good. I can give you example of glass rod and silk fur. Initially the glass rod and silk fur, there is no charge on it, so total charge of the system is 0. But when you rub that glass rod with silk fur, what will happen? The glass rod will acquire positive charge and the silk fur will acquire negative charge due to exchange of electrons between them. Resultant, the positive charge on the glass rod is of the same magnitude of the negative charge on the silk fur. And again, if you add the both positive magnitude of charge and negative magnitude of charge, you will get the answer 0. As initial, there was no charge in the system. After rubbing also, there is no charge in the system. So you can say the charge is equivalent, so they will cancel out each other. So you can say that the total charge on an isolated system is constant. Tell this clear 100%. Very good. Moving to the third law, that is now moving ahead to the third law, that is law of conservation of linear momentum. The third law we do have, that is law of conservation of linear momentum. Clear? So we are going to study about law of conservation of linear momentum. This law states that this law states that if no external force acts on the system, then the total linear momentum of the system remains constant. So I can write over here, this law states that if no external force acts on the system, the total linear momentum of the system remains constant. Total linear momentum of the system remains constant. Clear? If no external force acts on the system, then you can say the total linear momentum of the system remains constant. This is what the law states. Clear? Yes, students, make one thing. Make sure of one thing over here. You will able to notice that in linear system we use the word force over here. Clear? In angular system, or you can say rotational dynamic, we use word equivalent to force, that is torque. Clear? Which is responsible for what? Rotation, or you can say circular motion of an object, angular motion of an object. Till this clear? Okay. So moving to the next, that is law of conservation of angular momentum. Law of conservation of angular momentum. That is our last law of this four fundamental laws, or you can say basic laws in nature. That is law of conservation of angular momentum. Clear? In linear momentum, I have said that if no external force acts on the system, here no external torque acts on the system. So you can write over here, this law states that if no external torque, here question arises, sir, what is torque? Torque is nothing but twisted force. Twisted force responsible for the angular motion of an object. So torque, this law states that if no external torque acts on the system, the total angular momentum of the system remains constant. Here, of the system remains constant. So this clear with the statement? Very good. This any statement out of these four laws can be asked in 1 mark question in exam. Either you can say what law of conservation of energy states, what law of conservation of charge state, what law of conservation of linear momentum state. Clear? So you have to write this statement and give one possible example for that. Clear? So this law states that if no external torque acts on the system, the total angular momentum of the system remains constant. Hope it is clear, all the four laws. Very good. Now moving to the very important topic, that